So God bless everyone. In this topic, we're going to define technical terms or keywords that is involved in hypothesis statistical testing. Here are the key terms you are going to encounter in testing the hypothesis. Null hypothesis, alternative hypothesis, testing hypothesis, test statistic, p-value, critical value, type of errors, conclusion. What is hypothesis statistical testing? An objective method of making decision or influence inferences from sample data, evidence. Thus, there are hypotheses that are stated in such a way that they may be evaluated by appropriate statistical techniques. So, to start our topic, let us answer this question: what is hypothesis statistical testing? To make it simple, statistical testing is a testing of the formulated hypothesis you have created to answer your problem by using factual records that is being recorded by doing cases studies or surveys. This doesn't involve subject or emotional inclinations, but let us try to get to know more about this hypothesis. Why do we need to test it, or why is it important? Before proceeding to the first and second term, let us first decode what is hypothesis during our primary and secondary years. Hypothesis is simply defined to be a scientific guess or an educated guess. It is not usually expounded or tackled tremendously as long as is it formulated for away from superstitions that defy science. Later on, we were introduced to a newer concepts according to statisticians. Hypothesis is a statement about one or more populations. It is that not only involves a single or simple sample only but a population. It will not only look at a single perspective, just like we did in our earlier grades, but now it is usually concerned with the parameters of the population, not a simple individual or sample but lots of them. Hypothesis. It is a statement about one or more population. And the second one, it is usually concerned with the parameter of the population. Example, the hospital administrator may want to test the hypothesis that the average length of stay of patients admitted to the hospital in 5 days. With the example we had, it does not only aims to answer a question with a subjective point of view, but rather an objective one. Doing a hypothesis statistical testing, it does not only involves a single hypothesis. It actually involves two types of them. There are the null hypothesis and the research or alternative hypothesis. And who are these hypotheses? Let us first define the null hypothesis. Null hypothesis, what we assume is true to begin with. Typical that there is no difference, effect, relationship, etc. It is the hypothesis to be tested. The null hypothesis generally expresses the idea or no difference. The symbol we use to denote a null hypothesis is H subscript or 0, This is the type of hypothesis that is usually challenged or to be tested. The second type is the alternative hypothesis. Um, what we aim to gather evidence of, typically that there is a difference, effect, relationship, etc. It is a statement of what we believe is true if our sample data cause us to reject the null hypothesis. The alternative hypothesis, which we denote by its subscript 1 or even greater than 1, expresses the idea of some difference. It is the hypothesis that challenges the null hypothesis because it aims for difference or it defies the common norm or belief. Alternative hypothesis may be one-sided or two-sided. Usually, the setting of the problem determines the alternative even before the data has been collected. The problem given on our previous slides. Problem: the hospital administrator may want to test the hypothesis that the average length of stay of patients admitted to the hospital is 5 days. H0, the average length of stay of patient admitted to the hospital is 5 days. H1, the average length of stay of patients admitted to the hospital is less than 5 days. H2, the average length of stay of patient admitted to the hospital is more than 5 days. These are the hypotheses that can be formulated out of our problem. So since nga wala tay mapangutan-an ni classmates, so let's proceed to the next topic. Explaining the things in the context of the court case. Member of a jury have to decide whether a person is guilty or innocent based on evidence. The second one is the person is innocent, null. Alternative is the person is not innocent, i.e. guilty. Is a given scenario, we cannot just give a verdict to someone without finding the whole truth. Meaning, we need to gather evidence that could justify the plea that would be given to that person in plea. Remember, the null can only be rejected if there is enough evidence to doubt it. The jury can only convict if there is beyond reasonable doubt for the null of innocence. They don't know whether the person is really guilty or innocent, so they may make a mistake. With the help of hypothetical testing, we can come up with conclusion or decisions that we will give right justification. Now let us move to the next K term, which is the test static. What is a test static? Test static, this is a value that we will calculate from the sample data. The test static often follows a well-known distribution. Example, t-test or Cheeky square or even SPSS. The test static is a statistical tools or levels. We compare it to decide whether or not to reject the null hypothesis. It is obtained by taking the observed value, the sample statistic, and converting it into a standard core under the assumption that the null hypothesis is true. The value that will be calculated is the sample data that is obtained from the test you have run to answer your hypothesis. Now, here are some of the example of a test static. The next topic is chi-squared test, null there is no association between class and survival. Alternative, this an association between class and survival. 3 times 2 contingence table. Class survive cross deviation count. Muna siya ang example. So, the Cheeky squared test is a statistical tool that is used when we want to see if two categorical variables are related. The test is static for the Chi squared test uses the sum of the squared differences between each pair of observed 0 and expected values E. Next topic is using SPSS. Test statistic equals 127.859. So, chi squared test ng persons, chi squared, likelihood ratio, linear, bilinear, association, n of valid cases. Muna siya sa nasa value 127.859, 100.27.765, napon siya 100.709 sa association, sa n of valid cases kay 139. So nadi sa DF kay 2 tapos 1 sa ubos, and this the SPSS is a software that is run for statistical calculation. In SPSS, there are certain clicking of term you have familiarized in order for you to not mess up with the flow of calculation. In the example, the test statistical that is being used to identify whether the null hypothesis is being accepted or rejected in 127.859. Moving on, let's us try to know the basic kind of errors in the hypothesis statistical testing. All hypothesis testing is liable for errors. Two basic kinds of errors. Type 1 errors is incorrectly rejecting a true null hypothesis. False negative, the probability of type 1 error A is also called the level of significance. In a type 1 error, it occurs if the null hypothesis is rejected when it is in fact true. The second is type 2 errors is correctly failing to reject an untrue null hypothesis false positive. The probability of type 2 errors is denoted by in a type 2 errors, it occurs if the null hypothesis is not rejected when it is in fact false. And unlike A type 1, which is specified by the researcher, the magnitude of B type 2 depends on the actual value of the population parameter proportion. This is the result you get from doing your statistical calculation or computation. The calculated test statistic is compared to the sampling distribution that the statistic would have if the null hypothesis were true. The comparison is summarized into a probability called a p-value. This is the probability if the null hypothesis is true that the statistic would be at least as far from the expected value as it was observed to be in the sample. P-value, the technical answer. The calculated test statistic is compared to the sampling distribution that the statistic would have if the null hypothesis were true. The comparison is summarized into a probability called a p-value. So let's move to the next topic. The p-value range from 0.0 to 1.0 point as it approaches 0.0. It indicates that the sample is a rare outcome. The population is hypothesized. The closer the p-value is to 0, the stronger the evidence against the null hypothesis. When the test statistic is lesser than the p-value, then the null hypothesis is being rejected and the alternative is being accepted. So, the p-value range from 0.0 to 10 to 1.0. Note, the closer p-value is to 0, the stronger the evidence against the null hypothesis. Next is conclusion. The final decision. A decision is made based on the size of the p-value. When the p-value is small, i.e. less than the critical p-value, we reject the null hypothesis. When it is not small, greater than the critical p-value, we accept the null hypothesis. A decision is made based on the size of the p-value. When the p-value is small, i.e. less than the critical p-value, we reject the null hypothesis. When it is not small, greater than the critical p-value, we accept the null hypothesis. In the same way, if the value of the test statistic falls in the critical region, we reject the null hypothesis. The conclusion should as far as possible be devoid of statistical terminology. However, significance level should be stated. The assumption of the test is that the variable is approximately normally distributed. The assumption is less critical the larger the sample size. This conclude the things I believe to be essential is hypothesis statistical testing. If you have additions, please raise it in the nation. Again, the K term I include were null hypothesis, alternative hypothesis, testing hypothesis, test statistic, p-value, critical value, types of errors. These are the conclusion. And that's all. Thank you.